I'm Simone Collins from the Catastrophe and Reinsurance Symposium. Welcome to our video series. Today I'll be speaking to Dr. Joshua Soderholm, a thunderstorm scientist at the Bureau of Meteorology, about all things hail. Welcome, Joshua.
Thanks, Simone.
Okay, so let's do this. Can you explain to us exactly how hailstones are formed? These solid objects that rain down from the atmosphere, the ancient Greeks attributed them to Zeus, but I'm sure our understanding has evolved since then. So what's the crux of the science?
Yeah, we're definitely no longer priests predicting hailstorms. So let me bring up a slide that'll give you a bit more of an idea of what's going on here. So this slide here shows us a simulated thunderstorm. And the simulation gives us an idea of where the cloud is, which is the gray shaded areas, and where this important region within the storm called an updraft is, which is the yellow shaded region. And this updraft is so important because it's where we're seeing wind moving upwards within the storm, carrying all that warm surface air, warm humid surface air through the storm, where it produces the lightning, the hail, the rain. So in terms of how hailstorms form with respect to an updraft, you can see this blue line that's been drawn in the animation. And this is actually a simulated hailstone growing inside this storm. You can see it's taking this trajectory where it's falling into the yellow zone, but then it gets picked up by it because we have these winds moving up through the storm. And as it gets picked up by these winds, it's also growing at the same time because it's collecting all this water vapor, water droplets are condensating, freezing rapidly on the hailstone to a point where it either gets too heavy or it moves outside of this region where it can grow and it falls back down to the ground again, which is what we're seeing in the last segment. So this is essentially the life cycle of a hailstone. It starts as a little speck of ice, maybe only a few millimeters across, but once it makes its way into this updraft region, it starts to grow and grow and grow. And the size at which it grows to is dependent on how long it gets to grow and how much water there is within the hailstorm. So I got a couple examples on this slide here showing two different hailstones. So the one on the left is the more typical hailstone we see. This is still categorized as a giant hailstone, so it has a diameter of 5 centimeters. But it's experienced a moderate amount of growth where it's able to accumulate water up to that diameter. We do, however, see more extreme conditions where hailstones could stay inside the thunderstorm for even longer, tens of minutes in some cases. And that gives us the hailstones on the right here. So this is a hailstone which is 14.5 centimeters across. And it's, rather than a collection of little hailstones, no, it's not quite that. It's actually a hailstone that's grown icicles out of it. It's a single stone that's formed just by growing within this updraft region. So that should give you a pretty good rundown of where we've come from the times of Zeus to present.
So Joshua, we're interested in learning more about your work, especially as this peril is so costly, moves like a ninja, and before you know what has happened, has left a trail of destruction. Can you paint a picture for us of your day-to-day and how you came about to have such a passion for your research into hail and storms?
Right, yeah, so day-to-day for me depends on what time of year it is. So during the warm season, when we have a lot of hailstorms, there's obviously a lot of planning and there's a lot of review around events that have just happened. And after that's all done and during the off season as well, we also look at developing tools for forecasters to use. And of course, taking all the information we've collected from these storm events and turning it into exciting science. So that's sort of the day-to-day for me. But how did I actually get to this point? I guess you got to go all the way back to where I grew up in Brisbane, which, as many people know, gets its fair share of thunderstorms. However, I actually grew up in a part of Brisbane which didn't see many storms, which, as somebody who was quite young, enjoyed thunder and lightning, was incredibly frustrating for me. And I often wondered, why don't we get many storms when, say, South or West Brisbane does? So for me, that was sort of a motivation going forward, taking my passion for storms and curiosity about why some areas get more than others to end up where I am now. And I guess we're still answering that question, still trying to quantify thunderstorm risk across Australia.
Thanks. And what's the furthest a hailstone has travelled to find its way to your lab? And what are some of the protocols in place to give confidence that what lands in your freezer is actually what hit the ground or maybe a house?
Yeah, so we're unfortunate enough in Australia to work with universities in Queensland and New South Wales. So when there's events in those states, we have people up there who are able to collect them. And in terms of the hailstone which has travelled the furthest to get to one of these places, I would say it's probably from Mackay to Brisbane during the recent October 2021 event up in Mackay, where we actually saw Australia's record hailstone fell at 16 centimetres. So we're actually able to get some of those hailstones, thanks to the University of Queensland, down into their labs, and later on we're able to analyse them. In terms of the furthest I've travelled, I've actually travelled myself to Argentina to participate in a field campaign looking at hailstorms over there. And we've collected hailstorms in the field and transported them to be analysed. So that was an incredibly long way for me to travel to get to a hailstone, because I don't think you would survive the trip from Argentina to Australia. And yeah, on top of that as well, I guess in terms of how we actually know if this hailstone was a hailstone that fell at this time and has it changed or did it impact the house, etc. What we do is we talk to the people who actually collected them, because we're often not there. So we need to go back, talk to them, build up a timeline of the events, work out important things like how much they melted, how many hailstones fell within their backyard, what was the sort of sizes and shapes for all the ones they didn't collect. Once we pull together this timeline, it gives us much more confidence in what we collect and relating that to what actually impacted the area.
Joshua. And what we really want to know, when you wake up in the morning, what do you think about first? Hail, coffee, or the upcoming zombie apocalypse?
I would say living in Melbourne, a lot of the time it's coffee, except when you get to the build up to the storm season, September, October, November, where the activity really heats up. Those days it's definitely hail, because that's usually what's on the forecast for somewhere in Australia.
And with hail being such a local and sudden event, what reliable data sources do you actually have to be able to monitor hail events and trends?
Yeah, that's a really good question. So in terms of what we've had traditionally, it's been reports. So reports allow us to go back over the last 100 or so years and catalogue where people have encountered hail at the ground. However, these reports are biased by population centre, of time of day, and even the sizes we get in the reports are biased towards like cricket balls, hen's eggs, things like that. And moving on from that, what we can use as well is weather radar. So weather radar allows us to look within the coverage of a radar. So it might be 150 k's around a radar site, 24 hours a day, 365 days a year. And that allows us to detect and study these hailstorms, whether it's night or day. And it gives us a much better picture of where hail fell across the entire area, rather than just where people's houses and population centres are. So I can show you a quick example of that as well. So I've got a slide here showing a radar-derived hail swath from a recent event in Brisbane. So we have estimated sizes up to 80 millimetres and above. And we also have these little green dots, which are showing us where reports were made during this event. So while we get a lot of reports across the metro area, you can see a lot of these swaths for where hail was observed on radar don't have any reports at all. So in these places, the radar is incredibly valuable for us to determine what actually occurred, and over long time scales, what is the risk of hailstorms occurring.
Thanks, Joshua. And how has technology shifted to allow better monitoring over time? And where do you still see gaps when it comes to accurately reporting on hail events?
Yeah, so weather radars is definitely where the big shift has been lately. We've seen new types of weather radars roll out, which give us even more confidence where hail has occurred. In terms of where the biggest gaps are, I still reckon it's reporting, because radar is great for telling you what's above the surface, what's in the clouds, but it doesn't actually tell you what's on the ground. And reports are still the best tool for doing that. And you can often see by searching social media that there is actually a wealth of information out there. People posting photos, videos, actual hailstones with rulers next to them following an event through these different mediums. And at the moment, we're exploring ways to try and collate this information and get it back to where it really matters to forecasters, to the scientists, to better capture these events. So I reckon that's where we'll be going in the future, trying to better capture this information that exists on social media.
And we often see in the media the size of these hailstones and the smashed up houses and windows. What are some of the things you think that we in the insurance industry should be thinking about based on your research, especially damage that comes from storms where hail is a component of a broader weather event?
Yeah, that's exactly right. So with Australia's changing population, growing population, and also our changing styles of living, we're seeing exposure changing, of course, as well. And one of the trickiest things about this exposure is when we start moving into areas where we haven't had population before, so we haven't had any reports, and we're not really sure what's the long-term risk in those areas. So I think that's one of the biggest challenges for us going forward, is to try and to anticipate and quantify this risk before we actually see significant events impact these new regions. And another thing for me as well is, as we go forward, we're seeing new building materials being made available for constructing houses and commercial buildings. And we don't have a long history, of course, of understanding how these materials respond to large hail and giant hail. So going forward, it's also important, I think, to try to understand how these different materials changes the vulnerability of the structures or even cars which might get impacted. In terms of multi-day events as well, so that's a good question, because one of the most difficult things these days is trying to tie whether your hail event was associated with this flood event and this wind event, which might have occurred within the same week. So deciding rules around that, looking at the large scale meteorology, making informed decisions is very important. But then when we go into the actual events, we can also see now that a lot of the damage on hail days might have actually been caused by water ingress or by wind affected hail. So we're not only seeing these hazards occurring across a multi-day event, they can also occur within the same event, making our understanding of the damage a little bit more complex and trying to predict how it responds to these different hazards.
Thank you. And can you tell us more about the trends in the occurrence of hail? Do we have more data points through time, or is it fundamentally changing due to a changing climate?
That's something which we're looking into quite actively at the moment. So we have seen recently in a published paper that thunderstorm rainfall has been increasing, particularly over the East Coast, and we've been able to observe that using radar data. Hail's a little bit more challenging because one of the problems with hail is it's less frequent. So we may only observe it a dozen or so times a year compared to rainfall. So we are still looking at these data sets and now are approaching the lengths now where we can start to make statistically robust claims about whether we're seeing increasing trends or no change. And I'd expect the science to come out in the next couple of years where we can start to provide more informed decisions about our changing hail risk.
And what kind of efforts are you and the BOM undertaking in linking your research and investment with the broader community and industry, including the insurance industry?
Yeah, it's a very good question. So one thing which I'm quite passionate about is making the wonderful data sets that the Bureau collects available to the industry, such as the insurance industry, to be able to inform their own decisions. So we do a lot of work around making these data sets available and also providing the training through workshops and conferences where we get people hands-on using these data sets so that they can analyze them themselves without having to read about them in a paper. But of course, we're also taking this new information we gather from collected hailstones, analyzed events, we're putting it all together to produce state-of-the-art risk assessments across the country for our hailstorm environments. In addition to that, we're also improving the tools which forecasters have available to produce warnings. So that's sort of our three-pronged approach for data, science, and our operational products.
Thanks, Joshua. This has been great and I'm sure very informative for all of our viewers. So thanks everyone for joining us and we'll see you again next time.
Thanks, Simone.